Hello again, this is Tyler from the Singapore Green New Deal, and I'm here to answer your questions about the climate crisis, and also about the engineering and the policy solutions. For the detailed responses, as well as links to the original sources and some entertaining videos, do check out the links below in the description section of this video. So what are some good websites that we can search up to learn more about the climate crisis? Check out the links in the description, which include a written handout for all the information that's in this video, the Singapore Green New Deal website blog, where you can also find a crash course post, which has a repository for a lot of useful references covering a wide range of topics from climate science to engineering solutions, policy analysis, as well as how to get involved. Will we be able to completely get rid of climate change in the future? No. There's some minimal amount of warming that is guaranteed to occur over the next decades, and the associated extreme weather increases and destruction of habitat, which is essentially guaranteed based on the buildup of energy that's currently stored in the oceans and the excess carbon dioxide stored in the oceans as well, and also in the atmosphere, which is 415 ppm right now. The only thing that we have the ability to influence is whether we can make it worse or not by delaying the reduction of greenhouse gases and making it either an adaptable losses, which is something that we could potentially live with, or an unrecognizable future. So these are the choices that we have right now to make. And what's going to determine the outcome is how much emissions reduction that we can achieve. Next question, will Singapore sink one day? Well, probably not completely. Here's an animation of Singapore, a projection of Singapore's sea level rise at different levels. A realistic forecast based on the baseline scenario of 2 degrees Celsius warming by the end of the century is that we will have some loss of coastal areas, maybe 5 to 10% as you can see in this video, for a sea level rise of around 1 meter, but most of the island would still be above water. You can see some visualizations of what this would look like in the references that I provide below. The sea level rise of 2100 is fairly certain, with little that can be done either to make it worse or to make it better by that time frame. Sea level rise beyond 2100, though, is entirely dependent on what we do today. The last time that the Earth was at the level of CO2 in the atmosphere now, there were forests in Antarctica, no sea ice in the Arctic, and sea levels was 20 meters higher than it is today. If all of the Arctic and Antarctic ice melted, the sea level rise would be 60 meters, and most of Singapore would be underwater. But that would take centuries to millennia for those changes to occur. There are two factors that would determine whether this happened or not, and that's how fast we reduce our emissions globally, and also in terms of how bad the impact would be to Singapore would be the level of adaptive capacity that we have, and that means seawalls, etc. So how does the rising sea level affect marine life? Climate change affects the ocean in three ways: sea level rise, temperature increase, and acidification, which is caused by the increase in carbon dioxide. The rising sea level that occurs near the ecosystems that are near the coast, such as mangroves and corals, are ecosystems that are uniquely adapted to a specific depth and tidal zone. The thing is, if these changes occur gradually enough, which they will, then these areas most likely would just shift around, unless of course they shift into more developed areas, in which case that would be competing. But otherwise, it would just be a shifting from one place to another. The deeper marine ecosystems probably wouldn't be as affected by sea level rise alone. However, what is more of an impact for the entire ecosystem in the oceans is the temperature rise and the ocean acidification, which is a much more serious threat. This has the potential to lead to extinctions of some species that are at risk, or even the entire ecosystems. Species that are keystone species, such as whales and sharks, which are at the top of the food chain. Another issue that affects corals specifically is coral bleaching. Coral reefs in particular are likely to go completely extinct by the end of the century based on current locked-in emissions. It's unlikely that we'd be able to prevent this at this point. As you can see here in this video, this is an example of coral bleaching on time-lapse videos. This is what a dead coral looks like, and this is what a bleached coral looks like. You see how it's white? That's because the algae that it depends on for food leaves. Already there are mass die-off events for coral around the world by temperature-induced bleaching events, and this will only intensify and worsen. A reminder that 25% of the fish that we eat in seafood use corals as their nurseries, so there could be implications for the available seafood for future generations, as well as the indigenous communities and coastal communities that depend on these nurseries and the coral for their livelihood because of this locked-in threat that we have to the ecosystems. Now, for more information about the direct impact of climate change on marine life, do have a look at the 2019 IPCC report on oceans and the cryosphere.
Alright, I hope that answered your questions about the climate crisis. For the next video, I'm going to talk about the engineering solutions on how we reduce greenhouse gas emissions.